So first off, I want to say thank you very much for taking the time to do these interviews today.
Of course.
And if you wouldn't mind by just starting by introducing yourself and what you do.
Yeah, my name is Janine Captain, and I am the principal investigator for the Prime 1 mission.
Awesome. All right, so we'll just go ahead and get right into it.
All right.
So we've heard a lot about the importance of lunar water for future Artemis missions, but water ice isn't the only resource Prime 1 will be looking for. What is NASA hoping to learn about other volatiles like nitrogen or carbon dioxide, and how might those be used by future missions?
Yeah, so we're interested in everything that we can use on the lunar surface. And so when we go to that lunar surface, the first thing we want to do is really first learn about the soil. Because in order for us to use the resources, we really have to understand how to interact with the soil and what the resources are and essentially how deep they are. And so that's what Prime is really going to focus on. So when we drill into the lunar surface and bring the regolith or the lunar soil up to the surface, we'll release those resources or those gases, those frozen trapped gases that are there. And that's what the mass spectrometer is going to measure. So it will be able to measure any gases that come off the lunar regolith. So we can use CO2, we can use a host of other gases, but we can also use the lunar regolith in other ways. And so understanding how we interact with that lunar soil to drill or move, or even the thermal characteristics of that lunar soil, that will really help us as we use the lunar soil as a resource itself and go towards living on the moon.
Perfect, thank you. Now, next up, since the Viper rover has been put on hold, have your science objectives or priorities for Trident or M Solo on this mission changed at all to compensate?
So no, they have not. So we still maintain that we are going to do a technology demonstration of the drill and the mass spectrometer working together to really understand the lunar soil, the thermal characteristics. So the fact that it was delayed doesn't really play into effect of the other mission, but we will get a first glance at what we expect to see on that lunar surface. And so it will kind of better prepare us for when we are ready to operate Viper on the lunar surface, and we'll be able to more rapidly respond to what we see and maybe modify some of our assumptions going in to get some more accurate science.
Perfect. And that kind of ties into this next one. Besides Viper, are you looking at any plans for Trident or M Solo to fly on future missions? And what other opportunities do you have to get the same ground truth information about lunar volatiles?
So we'd always like to fly more instruments, especially this mission is Prime 1. We were hoping to get Prime 2 and Prime 3. Right now, we're looking at partnering with some commercial companies and responding to some of the NASA calls for future CLIPS missions. And we'll be able to analyze the volatiles in these other areas where these CLIPS missions are going. We're also going to be able to work with these commercial companies. There's a lot of commercial companies that are interested in the lunar resources. And so they're going to design the mission, and we're going to support their analysis by working with them and seeing what M Solo can detect and measure as they design their own missions.
Perfect. And lastly, how does NASA synthesize data about volatiles from so many different types of readings, like those from Prime 1, Lunar Trailblazer, and Micronova?
So that's a great question. And so on Prime 1, we have a small science team that is working the data that we measure with our mass spectrometer and our drill. That data gets synthesized and then gets put into the planetary data system. The planetary data system is open to everybody, and so we have scientists from around the world that are able to pull the data, and grad students and other science teams are able to synthesize our Prime 1 data with other orbital data and any other data that they can pull from that planetary data system. There's standards that allow them to have a nice, easy comparison and really understand where our data came from. And so actually, that's one of the things that we did in the Viper mission was we looked at all of the available data sets and how they could inform future missions. And so all of that came together with scientists from different areas, and we all brought expertise and used that to synthesize a plan for the best science we could get with our rover.
Perfect. Well, thank you so much.
Thank you.
That's all I had, so
Awesome.
appreciate it.
Thank you.
Thank you.
Yes.